Broadcasting live from our studio in Boston, Solutions Review is proud to showcase Cloudflare in the Solution Spotlight, a unique online event for industry professionals.
I'm Doug Atkinson here at Solutions Review, and welcome to this special Solution Spotlight series featuring Cloudflare and focused on deconstructing the recent HTTP2 rapid reset attack. This vulnerability allows a remote unauthorized attacker to cause an increase in CPU usage that can lead to a denial of service attack. For this presentation, Cloudflare has brought in a couple of technical experts who will cover the specifics of rapid reset and how you can defend against it. This is important information you should have, so I'll turn this over to Naila Rad, Senior Manager of Customer Success at Cloudflare, to walk you through the presentation.
Good morning, good afternoon, good evening, everyone. My name is Naila. I lead our customer success and partner success teams in North America for Cloudflare. I'm joined tonight by John and Rushil, and we're going to be talking a little bit about what we observed starting in late August 2023, specifically around Cloudflare and several other large content networks starting to observe a series of DDoS attacks. And our goal today is to ensure that you have information about our firsthand experience leading the discovery of the vulnerability and how we responded, with a deep dive specifically into the technical details. So we hope that you walk away with more perspective on this from our team at Cloudflare. If you have questions as they come up, please don't hesitate. We do have a Q&A. We are going to make sure we try to get to as many of those questions that you throw in that Q&A towards the end of the presentation. So keep them coming, and we're looking forward to answering those questions again towards the end of the session here today. So to jump right in, I am going to pass to John, who is our field CTO. John?
Yeah, I just want to introduce myself. My name is John Gates. I have been with Cloudflare for about 2 years. I live in Texas, and in my role, I spend a lot of time talking to other companies about Cloudflare, our technologies, what we do, what we're up to, and a lot about where we're headed as a company.
Great, thanks, John. And Rushil, over to you.
Hi, everyone. I'm Rushil. I'm a system engineer at Cloudflare. I've been with the company for about 1.5 years, and I work on the protocols team, adding new features and adding new capabilities for preventing DDoS attacks. Thanks.
Great. And with that, let's jump right in.
Okay.
John, I'm going to pass to you.
I will take it from here. Okay, so let's talk about sort of what, sort of the overall perspective of what this whole presentation is about. Basically, I want to frame it up as a, novel attack that was targeted at Cloudflare. So this has been termed the HTTP2 rapid reset. It is a flaw in the HTTP2 protocol. We discovered it in August 2023. That led to a global disclosure, worldwide disclosure, with the help of Google and Amazon as well. The impact of this was very serious. Nearly every single DDoS mitigation vendor, every web server software, anything that supports or talks HTTP2 protocol is vulnerable, or was vulnerable until it's patched. This was released very recently, so there are some folks that are rolling out patches as we speak. This was actively exploited. It resulted in some issues around the internet, specifically targeting websites at Cloudflare itself, and some of our customers as well. And the exploitation of this vulnerability led to a very large DDoS attack, a series of attacks, in fact, and we'll talk more about these, but just the highlights: 201 million requests per second, which was 3x the previous record that Cloudflare had ever seen of 71 million back in February. We saw lots of attacks, large ones, 184 that were larger than that record, and 107 more that topped 100 million requests per second. So that's kind of the high level. What we're going to do throughout this presentation is dig into some of the details, just to give you a little bit more behind the scenes, a little bit more guidance on what you can do to mitigate this particular vulnerability or this attack vector. And we'll talk with some people behind the scenes here at Cloudflare. So let me just touch here on what we did in the context of sort of disclosing the flaw that we discovered. We were one of the first to identify this, but we quickly realized that we were not the only one being targeted. We obviously have some back channel communications with our peers in the industry and other folks that share relatively important security information. So we and Amazon and Google sort of have joint ownership around the disclosure of this flaw, and we did that disclosure on October 10th officially to the public in the form of a CVE, which we'll talk more about. We also disclosed this to other partners in the cybersecurity industry, people that are officials in the government, CISA, for example, making sure that there were, sort of people in the loop on this. We also did some behind the scenes disclosure to some information sharing groups that are under NDA, so that we made sure they were aware in a timely manner. And we coordinated, making sure that we wanted to coordinate the patch rollout so that we did this in a way that didn't give anybody else the upper hand in terms of leveraging this mechanism to attack other folks. So so it was basically an industry-wide collaboration, and this is all in really support of Cloudflare's mission as a company. Our mission is to help build a better internet, and we believe this kind of disclosure and this kind of information sharing is super important to have a robust and secure internet as a whole. So that's sort of the behind the scenes in terms of how we communicated. Let's dig into the protocol itself and maybe sort of unpack how this flaw is used in this context. So looking at the graph on the graphic on the right, what you're seeing is basically the breakdown or distribution of traffic across Cloudflare's network. So you see at the very bottom, it's a little hard in the dark orange, it's representative of HTTP 1, the middle is HTTP 2, the top is HTTP 3. So you can see that the vast majority of the traffic is HTTP 2 or 3. That's roughly 90-something%. So maybe I'll throw it over to you, Rashil. Maybe talk a little bit about sort of why this protocol breakdown looks the way it does. Maybe talk a little bit about the protocol itself and your experience, things that maybe you want to share in this context, and then I'll jump back in.
Yeah, so as John just mentioned, the rapid reset vulnerability is specific to HTTP2. And there's a couple of reasons why that is. So I'll head over to the next slide here, as it kind of has a good breakdown for that. If we could just. So to basically compare and contrast the two protocols here, in HTTP 1.1, one of the limitations is that you basically have to wait for it's kind of one request at a time, right? So the general advice to have multiple requests going on in parallel is to open multiple TCP connections, and so it doesn't really lend itself to quick ramp ups of traffic. This obviously has performance implications because you can do less with one TCP connection, and there was obvious room to optimize. So to summarize, HTTP 1, you send a request, you get a response. You send another request, you get a response. It's kind of one by one. HTTP 2 worked around this limitation and added a concept of frames. So you don't just have to send. The problem in H1 was, well, how do you distinguish multiple requests from each other, right? You're just sending raw bytes over the wire. But with HTTP 2, there was a lot of there was some constructs added on top of the actual binary protocol, so frames, stream IDs, that allow both client and server to say, okay, when I'm receiving the sequence of bytes, it's actually for this request and not another one. And so what this means is now a lot of clients can leverage HTTP2 to send multiple requests at once, interleave them, and get a lot more performance out of that. Unfortunately, this also ended up opening a whole new suite of attack vectors for DDoS attacks. So now, essentially, what the attack vector is for rapid reset is HTTP2 also allows you to reset streams, right? So when you are sending a request like I mentioned before, there's this concept of streams, which basically maps one-to-one with every request that's sent over the wire. And in order to actually manage this life cycle of sending a request, sending a response, sometimes you want to cancel a request, and sometimes you want to let the server know we don't actually care about receiving this response, or we don't want to consume that response anymore. For example, if you open up a page in a browser, you load up a ton of resources over H2, you close the browser, a lot of those requests that are still in flight, you obviously don't need anymore. So you can send something called a reset stream over on that stream ID, basically informing the server you don't care anymore. What this does on the client side is it basically allows you to free up that stream. So in HTTP2, there's also a concept of max concurrency, which basically is a number that designates how many concurrent streams you can have open at once. So uncapped, this would obviously be super dangerous, because then any client out there, especially malicious ones, can just open a ton of concurrent requests and flood the server. So the protocol itself has this value that's meant to control that naturally. But and given the client and server have different, basically they have to maintain this state separately. So when a client resets a stream, it basically frees up one of those values to be used again. So let's say the max concurrent value for the protocol, which is negotiated, by the way, between the client and the server. Let's say it's 100. If you send a request and immediately reset it, you'll get that request back into your pool of 100, which is kind of the bread and butter of how this vulnerability works. So that's the high-level overview of what's the difference between HTTP1, HTTP2, and why HTTP2 kind of opens up the opportunity for this vulnerability.
Yeah, so lots of folks, obviously, we saw that number 60+% have moved to HTTP2. So it's a very large, relatively speaking, portion of the traffic. Therefore, when it's abused, it's a real problem, right? The widespread use of HTTP2 underlines really the critical nature of addressing this vulnerability. And then what you just talked about is the performance advantage of HTTP2 with the new features that were added to allow for some of that stream cancellation is really what was being leveraged to abuse this system. So it's, in a way, this is really a protocol vulnerability, not a bug per se. It's not like a coding error that somebody made, or a problem that can just be readily remedied with a fix. It's really something that is inherently required, sort of in the code, in the protocol itself. And when you abuse that, it becomes really problematic, because it's meant to be used that way, right? I mean, by definition, this is a feature to be able to open and cancel, basically request cancel. That is, by definition, part of how it's supposed to work. But then the problem comes in when people, abuse it beyond the scope of what is expected or what is capable of being handled. And that's where we get to this next slide. We dig a little deeper. We start to look at some of the packet captures that that our teams behind the scenes had to go through when they were starting to try to diagnose and dissect what was going on. Because initially we really didn't know what was going on. It was like a DDoS attack, and until normal DDoS attack, just larger than we had seen before. But when you start to look deeper into the packets and you see this, this GET request, and I think it's been highlighted here. You can sort of see the request with the GET in the headers there. You can see the cancel comes shortly thereafter. Another request, another cancel, another request, another cancel. So you have sort of this back and forth, GET and reset. And then you have to also remember that, a lot of these can be packed into a single packet, basically a 1,500 byte packet. You can fit about 47 of these requests into one of these sort of normal size packets. And that means that the attacker can require the server to burn a lot of expensive CPU resources dealing with all of this stuff. So maybe talk a little bit about that. Maybe you can probably go into more depth than I can, but tell us why that sort of idea of resource depletion, tell us what that means.
Yeah, so the name of the game for DDoS is when you have some operation that's very cheap for the client that ends up kind of resulting in a lot of work for the server, or relatively more work. And this slide right here is a prime example of that, right? You can send a lot of requests, in a single packet that will, because of HTTP2, you can concurrently send a ton of these GET requests at once, and a lot of servers, when they process these requests, will basically, as soon as they see a headers frame, will immediately start processing it in some state machine. And by the time you cancel it, that request will get freed up eventually, but maybe you've made a couple connections to some external servers down the pipeline at that point, and it does take some extra work to clear some of that up. And because these attacks can ramp up so fast, that can have a lagging effect and leave you in a state where you're consuming a lot more CPU or memory than you may want. So that's kind of the fundamental issue there. Very, very cheap for the client, but actually ends up in a disproportionate amount of work on the server side.
And another thing to remember here is that this is happening at HTTP, which is layer 7, right? This is the top layer of the stack. It's where, kind of the most work has to be done by the server to deliver whatever it is it's supposed to deliver. This is not sort of a network layer down at layer 3, 4, like a lot of the old school reflection attacks that we used to hear about. This is really processing requests at layer 7. It's very computationally expensive. It involves various steps from the server's point of view, lots of things going on. And also within the context of Cloudflare's network, there's a lot going on because it's, again, layer 7. So it's very much the victim's burden and the attacker's advantage in this context, because they can send those malicious packets with relatively computationally simple techniques. On their side, it's easy. On the target side, it's a little bit more complicated. And hopefully this slide has broken it down a little bit for you to understand how this works, the get and the reset pattern, the back and forth. It really is a challenge when you start to throw lots of these packets. That's what basically they did. They were using a relatively small botnet. This was, I think, 20,000 node botnet, which is fairly small by today's standards, but it packed a punch. It created a very large DDoS in the case. I think we've got a slide on it. I won't spoil it, but we'll move on to the next one and we'll talk about the scale, the relative scale here. So I mentioned that Cloudflare had seen a 71 million requests per second DDoS back in the February timeframe. I remember it because it was right around Super Bowl Sunday. I believe it was that weekend, in fact. And that to that time had been the largest DDoS that we'd ever recorded. And I think at the time, the largest DDoS that anybody had recorded. And here we do sort of a fast forward into August, late August. And now we've got this 3x increase, massive increase in terms of the size and the scale of the attack. And so, and it wasn't just one, it was a number of these attacks. I mentioned earlier on that there were a series of these, 184 attacks greater than that 71. So you can see very quickly that this was, a large scale attack. It wasn't some script kiddie playing around with a new tool. This was something that was, pretty substantial. The unexpected magnitude, just really caught us off guard, but it really forced us to start, putting our best efforts into figuring out what was going on. And over the next 30 days or so, we sort of had this cat and mouse game where we implemented some mitigations. We saw the attackers adapt. They would find ways around them. They varied their attack patterns. They would change the rate of requests. They would change the number of IP addresses. We'll show you some graphs on that. And sort of this continued evolution really spoke to the idea that this was a more sophisticated threat actor than just some script kiddie with a new toy. These were some people that were looking to sort of use Cloudflare as a target to test. And in fact, in the title there of this slide, it says Cloudflare was attacked, and we were attacked. We were targeted with the attack against Cloudflare itself, and that was really in hopes that the the attacker could sort of figure out the effectiveness of these attacks against a robust service like Cloudflare, and that would lead potentially to them being able to sort of turn around and sell this attack and sort of advertise its capabilities in terms of the effect on Cloudflare's network. Again, the mitigation was only possible by this continuous effort by our engineering teams, our reliability teams. They created new strategies, they created new code, they implemented new technology in our stack to take care of some of this. And what you see there with that sort of regression line, I guess that's maroon or a color there that shows sort of the relative decline in the size and the scale of the attacks, and that was only based on the mitigations that we were putting in place. What did I miss on this slide? Anybody want to chime in there? Maybe give us a little more flavor of anything I've missed there.
Yeah, some insights from the engineering side. A big part of dissecting an attack like this is observability. So we needed to make sure we had insight into exactly the various characteristics of the requests, all the behaviors that the clients are exhibiting during the attack. So that was a key part. We had a lot of existing observability infrastructure to rely on, which helped us recognize that every attack was displaying the same spike in client sent RSTs and in stream cancellations. We had to add some new observability to get more insight on various request characteristics, and that's ultimately what helped us really hone down on figuring out a patch to prevent this specific vulnerability. And
that observability is super important, because you got to know what you're looking for, right? And then if they're adapting and changing, then we sort of have to tune and change in lockstep with that, right?
Yeah, exactly, and that's what we saw, right? A lot of what happens during these attacks is you'll be honing in on some characteristic, and they'll tweak that very quickly, and they'll come back with a new flavor, right? So making sure you're on top of understanding what exactly the clients are doing, especially the malicious ones, is very paramount. And that was a very big played a big role in us being able to mitigate this.
Yeah, it's really crazy that a moderately sized botnet, 20,000 machines, was enough to harness this kind of impact, or this take that vulnerability and turn it into an attack of such enormity. I think truly only a handful of folks on the planet could handle this. I obviously am partial to Cloudflare's engineering team. They've got some very capable folks behind the scenes. The infrastructure that they manage every day globally around the world is top notch, and it's really really cool to look behind the scenes and see them take our state-of-the-art DDoS defense mechanisms and adapt them in real time. I mean, this is like a real-time battle back and forth to make sure that we're protecting our customers. Obviously, some of that spilled over, that we did see a few disruptions here and there, but nothing that was a huge hit. It was just sort of here and there we had customers. So let's keep going. We'll talk about we'll get to some questions here in a minute. But if you do have any questions along the way, put them in the chat now so we can address them toward the end. I should just remind folks about that along the way. So this slide that you're looking at now, sort of it is reflective of that, what I mentioned, that cat and mouse game of an attack pattern where they try something, it succeeds for a little while, then Cloudflare figures out how to defend against it, and then that same attack no longer works. It's really representative of IP addresses being added to the pool, so they were basically utilizing more attack sources, more IP addresses in the pool of the botnet. And basically that was one of the variations they were using. They were also varying the duration, the intensity. They were trying to figure out the best way to effectively carry out, sort of an attack using this exploit. And that is something that is typical, but it's one of those things that again takes a lot of engineering and a lot of monitoring, looking at where those things are coming from and making sure that we're adapting. to that. Anything else to add on this one?
Yeah, like you mentioned earlier, the botnet wasn't too big, and this is one of the key ways it was able to cause so much harm, right? When you're rotating IPs like this, layer 4 blocks become hard, and naturally, because of this vulnerability, layer 4 blocks aren't as effective because you have so few connections outputting so many requests, right? In HTTP1, it's more or less a one-to-one mapping of connection to request, at least one at a time, and so you can't scale up as fast. But now that you can, put, n number of requests into a single connection, a lot of layer 4 visibility goes down. And on top of that, we have the attackers rotating IPs frequently, right? So it becomes a whole new class of problem where you need to find, new ways to mitigate what's happening.
You bring up a point that maybe we could discuss here for half a second, is the idea of blocking this at the IP level versus doing mitigations at layer 7 or elsewhere in the stack. And obviously, if you know where the attack is coming from in an IP address, you could theoretically block the IP address, but that tends to be sort of a blunt instrument because it could potentially block things that are not bad, sources of traffic. They could block some good sources of traffic. So do you want to talk about that here, or do you want to mention that somewhere else in the conversation?
Yeah, no, this is a great. So it's you really need a tight feedback loop between your detections and between detecting the attack and actually being able to do something about it, right? Because when they're changing IP ranges this much, like you said, you really can't rely on just saying, okay, we've identified this IP as bad, let's just block it, because that's going to be a very short-lived victory, right? As soon as they get access to new proxies, new IPs, they're gonna kind of be once again able to hit your edge and cause damage. So our systems work in a way such that when we see traffic, we're able to kind of compare it to a whole repository of known fingerprints that we know to be bad. We have a whole system around this, and even that feedback loop can be tested in times like this. And so, like you said, you need a lot of mitigations in the layer 7 stack itself that's able to kind of fight off this specific attack pattern. Like when you're seeing, when you're seeing a very kind of niche attack pattern of sending a request, canceling it in short succession, then you kind of have to take action and not rely on maybe a less latent kind of pattern of blocking IPs.
Yeah, and just for relative scale, just when you look at that graph, I mean, the blue bar was like basically an initial 18,000 IP addresses, proxy servers. And then later on, they added something like 60,000 more. I mean, this is a crazy number of IP addresses. Even if you did know what to block, it's still not trivial to actually carry out, blocking and taking that into account. It's just something that you really have to have a system for. And I think, thankfully, Cloudflare has a number of systems that work together in that context. So let's keep moving. We'll get to maybe another view of the attack. This is a geographic view of it, sort of the diversity of botnets. What you see here represented is where the source countries are from a DDoS perspective. So, the top one is the United States, India, under that is Germany, Indonesia, Brazil. Nothing huge to take away from this other than it's a typical DDoS. I mean, the D in DDoS is for distributed, and so you tend to have these servers that are being used or leveraged. They could be servers, they could be devices, they could be compromised, computers of any sort, and they tend to be where the internet lives, right? So the United States, India, Germany, there's lots of people there. They have lots of devices. They tend to be in the same kinds of places where we see populations. This is also probably a good place to talk about, maybe how Cloudflare defends against these kinds of attacks. We have a very geographically diverse network at Cloudflare. It lives everywhere around the world. It's in 300 cities, 100 different countries, and it's very close to the population centers, the same places that you're going to see these attacks sourced from. And that's where Cloudflare leverages its network to block these attacks or to counter these attacks. We want to do it near the source. We want to try to make sure that the traffic isn't being dragged all the way across the internet. And we certainly want to defend it before it gets to the target. We don't want it on your network. We don't want it on our customers' servers. We want to defend against these attacks at the edge. And that's really the mechanism that we use, is by locating Cloudflare's infrastructure near the source, we can mitigate these attacks very early. Did I get all that right? Anything else you want to add on that one?
No, that's all good.
Okay,
yeah.
Good. Okay, so this is the sort of the meat of the slides in terms of recommendations, what you should do, what you should be thinking about. And obviously this is something we've been talking about for a couple of days now. Some of this has already made its way into the news, but we can talk about it maybe at a little deeper layer here, just to sort of reflect on what we've talked about throughout the conversation. So I just said it, we want to block these attacks before it reaches your perimeter. We want to block layer 7 because that's where we identify the attack. We can't see this in layer 3, 4 necessarily. We don't have the sort of visibility inside the packet, so you're not going to be able to detect a HTTP 2 rapid reset inside of a packet unless you're opening it up and looking at the request. In this case, Cloudflare does a lot in terms of decryption, because HTTP is oftentimes coupled with encryption because of the nature of how we like to secure our web traffic. So we need to open up that, decrypt the packet, look inside, and make sure that that is attack traffic before we can really do anything with it. Another recommendation I would say is for companies that have infrastructure in lots of places. Cloudflare serves very large companies down to very small companies. It's really a range of size of customer. And so that means sometimes people are in their own data center, sometimes they're in multiple clouds, sometimes they have applications that are very distributed around the world. And so ideally what you would have, and what we got asked this a lot this week, people would ask, how do we know if we're covered? How do we know if we have full coverage across all of our stuff, right? And they want to make sure they're protected. And having a consistent DDoS control plane, and when we say control plane, a single place to control, to define policy, to see logs, to manage your infrastructure from a DDoS mitigation perspective. If you can do that in one place, it's advantageous, right? It would have been really easy to wake up the day of this, release of the CVE and say, are we protected? And you could look across your entire IT estate and say, yep, we're protected because we've got all this coverage with being proxied through the Cloudflare network. And so that's a recommendation we're making. There are companies that leverage multiple DDoS providers, but ideally you would have as much as you could in one place. Another recommendation is really making sure you're applying patches. This seems like obvious common sense, but make sure you have got the latest web server patches and OS patches and have applied those to your entire infrastructure, and making sure, certainly prioritizing the ones that are internet facing. There obviously can be things behind the firewall, so to speak, or on internal networks, and those are certainly a lot less vulnerable because they're not capable of being seen by the general public, but certainly eventually you want to patch those as well. Last resort, I guess, if you needed to, you could turn off HTTP 2 and 3. I would say, don't do that if you don't absolutely need to, because it's going to kill the performance of your web server. It's going to take a lot more resources to serve. I mean, certainly browsers will fall back to HTTP 1, but it's not going to do any favors for your web infrastructure to do that. And this last bullet point, again, it's for some of the larger companies we talk to. Sometimes they have a different DDoS provider. Sometimes they have somebody who is not on the front lines like Cloudflare was in this case. And it might be a good case to make to have multiple DDoS providers in your Swiss Army knife, in your arsenal, having a little bit of extra oomph in your protection there. So maybe I'll just ask you, Rachel, I mean, what's the answer to this question down at the bottom? How do you know you're protected? How do you know if your infrastructure is protected?
If your assets sit behind Cloudflare, as in, when your end customers are actually connecting to your website, if that traffic flows through Cloudflare, you are protected. We've, taken a number of steps and implemented a number of patches within our web servers to make sure that, the rapid reset attack is mitigated. We have a whole chain of proxies that handle requests, and we've done work in in multiple places to ensure that this kind of attack pattern cannot be exploited against our customers. So yeah, again, if you're using Cloudflare and your traffic sits, if your origin servers sit behind us, you're good and you're covered.
Okay. This is sort of my wrap-up slide before we take questions. So I think, obviously, we want to provide you with as much resources as we can. We have created a special web landing page there at cloudflare.com/h2, which links to more information about the Rapid Reset, all the stuff we know about it, including a couple of blog posts that we posted yesterday that have lots of detail, lots more than we could ever hope to cover in a short webinar. But you can go read about this stuff on our website. There's lots of resources if you need help defending against an attack or something you think is an attack. It's really important to be resilient, obviously, in the face of these evolving cyber threats. Can't do it alone, right? I mean, it's just not possible anymore to try to mitigate this kind of stuff at the scale that it's happening. If you want to stay up to date on what we're doing, we'll post anything new that we learn on our blog, and it'll certainly be linked there. I think, just thinking bigger picture, there's certainly parallels to things like the Log4j. Cloudflare was very early to defend against Log4j as well. We had WAF rules created very quickly. We rolled out protections for our customers, for all of our customers. And I think there's even parallels here with when you think about the way that this attack evolved. I don't think that this is the end of it. I think there's potential for this to evolve even more as the threat actors, everybody in the industry, and now everybody in the cyber attack community starts to sort of dissect this. They might learn some new mechanisms, some new ways to leverage this, and so what works today may not suffice for tomorrow's challenges. So it really underscores for me the necessity to be vigilant, to have continuous protection and adaptive protection. This is not a once and done kind of a thing. It doesn't end with a patch. It may not even be solved with a patch based on the conversation we had about it being a protocol challenge. So, making sure you have that protection and then support around it as well. Cloudflare has a lot of customers that need some help sometimes sort of more advanced understanding, more advanced, sort of emergency capabilities. We're capable of applying a lot very quickly in the face of these kind of attacks. We will continue to work with the community. Cloudflare always wants to share our experiences. We want to learn from others. We want to share our learnings, and we want to provide you with the best resilience that you can. And we want to express gratitude for you tuning in here. I personally want to thank all the people behind the scenes at Cloudflare who played a role in this, in protecting our customers and in learning what this was so quickly. So maybe I'll stop there. We've got a few minutes left. We can maybe take some questions. Is that fair?
We've got a few questions rolling in here, and if you haven't yet posted your question, please do. There's a little Q&A prompt there, and you can send that on through. I'm actually going to take us back, John, Rochelle, thank you so much for the time. I'm going to take us back to this slide because it looks like this is where we have a good number of questions coming in. Well, just to kick us off, Rochelle, I'm going to pass this one to you. Someone's saying they're surprised by the recommendation to turn off HTTP 2 and 3, specifically with 3. Is HTTP 3 affected, was the question.
Yeah, so the way HTTP 3 kind of handles, request multiplexing is a bit different, and we haven't observed anything directly impacting HTTP 3. But we're constantly analyzing the protocol and analyzing attacks that come in to ensure that there's nothing wrong. And if we identify anything, we'll we'll immediately hop onto implementing and patching that. But currently, we have not seen anything able to abuse HTTP 3.
I think that when this recommendation was put in, it was just a sort of an uncertainty level around, the what if somebody figured out a way to abuse it. We knew that HTTP 1, didn't have this potential vector for attack, but I think that the folks I heard from said, we just weren't 100% sure. So this was the only surefire way to sort of, as a fallback. And like I said, it is a last resort. We don't recommend necessarily anybody turn that off, either one of those protocols, if they don't absolutely have to. In the case of some of our customers, we were recommending, some of our really critical infrastructure customers, people doing things that absolutely must be online all the time. And if you were in a situation where you really had to fall back to some sort of known goods state, it would be in terms of turning off both protocols, and that would theoretically mitigate these kinds of attacks 100%.
Thank you. The next question I see here is for Cloudflare customers. I know we've spoken about this, but just very directly, have you implemented these recommendations? So have we at Cloudflare implemented these recommendations for our customers to make sure that they're protected?
We have. I mean, we have implemented a lot of the things that we learned early on into our infrastructure to defend against this type of attack. So it's not possible at this stage. We don't, certainly things can change over time, but at the current moment, we are protecting everyone that is, behind Cloudflare from abuse via the HTTP2 rapid reset vulnerability. I don't know if Rochelle, you want to say anything more to it than that, but yes, we are protecting our customers. We have implemented the protections. We created the protections basically into our platform, and then shared our knowledge about those to others to do the same.
Yeah, and I would add, if you are a customer and you have any concerns about your current security posture outside of Cloudflare and you'd like to chat with somebody, please reach out to your customer success manager, reach out to your account executive. You have a team, we're here, we want to help. So don't hesitate to reach out to your existing account team. I'm also going to just bring up this website again. You can also, even if you are not a Cloudflare customer and want some more information, please don't hesitate to reach out. We're here, we want to help. So if you do have concerns, definitely reach out to us. The next question is actually a more futuristic question. So John, I will pass this one to you. What do you foresee in terms of the future of DDoS attacks?
Well, it's obviously there's no such thing as a crystal ball in this world, right? You can't really see the future, but you can sort of predict what might happen based on past patterns. If you plot a trend line from sort of the history of DDoS attacks all the way through that 71 million requests per second that we saw in February, and then you see where we're at today, over 200. I think maybe Google even saw maybe a 400, something really, sort of even larger and, exponentially larger than what we'd seen before in a way. That is an indicator that, the attackers continue to learn, they continue to adapt, they create, they somehow pulled this out of thin air. Like, for years, this HTTP2 has been in this state. This is nothing that was created from a vulnerability standpoint. It was there the whole time, right? They just figured it out. They figured out a new way to abuse the protocol. And we know that there's no such thing as perfect in terms of protocols or code or architectures or whatever. So it's going to continue, right? The DDoSes keep getting bigger. We've seen that trend, and I predict they will continue to get bigger. They oftentimes are part of broader campaigns. So don't think of DDoS as something that stands alone. Sometimes it's accompanied by a phishing attack or a sort of ransomware attack of some sort. Sometimes it's an indicator that they are testing you to see how you respond, right? It's a very low cost way sometimes of getting the attention of a company and then seeing how they react and respond and seeing what kinds of protections they have in place. And so, for me, the prediction would be, stay vigilant, because these are not getting any smaller. They're not getting any easier to defend against. There's no magic wand that we can wave to make the bad guys go away. These things are problematic, and even the sort of reasons behind these attacks are continuing to change. Used to be it was some sort of vandalism. Now it's sometimes hacktivism. It's people going after another entity or country or whatever it might be. Sometimes it's ransom. We see DDoS is accompanied by a ransom demand. So I would say the reasons are going to continue to change. The tactics are going to change. the scale is probably going to grow, and it's not going to get any easier to defend. And so you really, again, need something like Cloudflare in your corner to help to protect you.
Thank you, John. I have time for one last question. So I'm going to go in terms of order of when the questions were submitted, because we're not going to be able to get to everyone's question this evening. The last question over to you, Rashil, just asking about how HTTP2 is different from HTTPS.
Yeah, so HTTPS basically the secure just signifies that you're using TLS to establish the underlying layer 4 connection. HTTP2 in most cases does imply HTTPS. And the same goes for HTTP3, and most traffic on the web nowadays is encrypted via TLS. So basically HTTPS and HTTP2 have significant overlap. Yeah.
Perfect. Thank you. I do see that we did not get to everyone's question. For those of you whose question we did not get to, we are going to follow up with you. So thank you for joining, everyone. John, Rashil, thank you so much for your time. And thank you to the broader Cloudflare team that made this happen. And thank you to all of you for taking time, evening, afternoon, morning, to join in and listen in on this. If there's anything at all that we can support with, we're here to help. Don't hesitate to reach out. And have a good rest of your day. Thanks, everyone.
So there you have it, a very challenging solution in our spotlight. We think this is important information, and we want to thank Cloudflare, Nayla, John, and Rashil for that presentation. And if you need any more information, you can go to cloudflare.com. Until next time, I'm Doug Atkinson here at Solutions Review. Thanks for watching.